the Mandelbrot Set, an infinitely deep and arguably one of the most beautiful math concepts of all time.
But first, we need to understand the complex plane. There are real numbers on the x-axis and imaginary numbers on the up and down. So here I'm writing down the format for plotting points on the complex plane. So for negative 2 plus 3i, we would go negative 2 over and 3i up, likewise for the other point. The Mandelbrot set can be defined as iterating by f of z equals z squared plus c from 0, where c is a complex number on the plane. But let's take a second to reel it back. Iteration is basically another word for repetition. With this equation, we can determine that there are two possibilities. One, that this number gets infinitely larger, or two, that the number stays within a close range near 0. For the first possibility, let's take the example of f of z equals z squared plus 3, where 3 would normally be a complex number. If we start and plug in 0, we see that we get 3. But then when we plug in 3, we see that we get 12. But then when we plug in 12, we get 147. And this means that the number is going to get infinitely larger if we keep on plugging in the results into our condition. Now let's do this again, but instead of adding 3 each time, what happens if we subtract 3? So if we plug in 0, you see that 0 squared minus negative 3 is, you guessed it, negative 3. But when we plug in negative 3, negative 3 squared minus 3 is 0. But wait, we already know what happens to 0. 0 squared minus 3 is negative 3. Thus showing that as long as we repeat this pattern, the numbers will stay consistent and not really move away from 0. So this is an actual visual representation of the Mandelbrot set, and if we look here, it already has everything we already talked about. It has the real axis over here on the x from left to right, and on the up and down we have the imaginary axis. And this is the constant c, which we discussed earlier while iterating around 0. And so here we can see, get it? Because like the constant c. Okay, yeah. We can see that while we stay inside the Mandelbrot set, the numbers stay contained and never really move around from 0, as long as we stay inside this little bubble. But as soon as we exit this bubble, the numbers explode out to infinity at random. And this basically explains the two cases we discussed earlier. The first case was when we were iterating, the number kept on getting larger and larger out to infinity, and that represents going outside of the Mandelbrot set, versus the second case where the numbers sort of took this pattern where they stayed within a certain range near 0.